Hi everyone, welcome back to my classroom. I start AP Calculus class from today. This is the first lecture. So I start from the second semester of AP Calculus, which means derivative, an antiderivative or integral. So let me start for antiderivative first. Okay, antiderivative or indefinite integral of a function fx is a function large fx. We usually use large fx to represent antiderivative or indefinite integral of the function fx, small fx. Suppose small fx equals 2x. So large fx, what is large fx means? We call this as the integral of small fx. Large fx means original function if the small fx is a derivative function of large f of x. So this, if small fx that equals f prime of x, and then just find what is original function large fx. Everyone knows that is x squared, right? Because x squared derivative is 2x. So integral is kind of backwards derivative. Backwards of derivative. Okay? Derivative of x squared is 2x. That means integral of 2x dx equals x squared. We use this notation. Integral dx. Integral 2x dx. That should be x squared. It's not done yet, but basically it's basically x squared because x squared's derivative is 2x. What about x squared plus 1? X plus 1's derivative is still 2x because any number's derivative is 0. Okay? So integral over 2x is a backward derivative, right? Integral over 2x. In this case, not just x squared, it may be x squared plus 1. Because x squared plus 1's derivative is 2x. What about x squared plus 2 derivative? That is still 2x. So integral backwards, right? Integral of 2x dx may be x squared plus 2. So actually any numbers doesn't matter, right? Plus 0 or plus 1 or plus 2 plus negative 5. X squared plus any number's derivative is 2x because any number's derivative is 0. So actually what is integral of 2x dx is equal to? The final answer supposed to be x squared plus c. Any constant is no problem because any number's derivative is going to be 0. We call this c integral constant. So for indefinite integral of fx, you have to always put c. Okay? Always you have to plus c. So you just understand, oh yeah, backwards of derivative is integral. So you already memorized a lot of formulas, right? A lot of derivative. For example, what was the sine x prime? What was derivative of sine x? What was the formula? There was cosine x, right? Now you can guess it. Yeah? The backwards of that derivative is integral. So integral of cosine x dx should be sine x plus c. Okay, so I'll give you basic formulas about indefinite integral of the function fx, the basic functions integrals, but most of them is already you know because already you learned before. When you learn the formulas of derivatives, already learned that the backwards of that formula of derivative is integral formula. So let's go to see basic formulas. Number one. K times fx. K times fx integral k times fx dx. So k is just kind of coefficient, right? Just number. So that number can go to front. So that is k times integral fx dx. In really basic rules. And the second rule is kind of addition rules. Integral fx plus gx is integral fx dx plus integral gx dx. You can find that integral from each function, fx and gx. Okay, from number 3, okay, the basic rules here. First, we're going to power rule. What was x to the nth power's derivative. The formula was n times x to the n minus 1. Okay? The backwards of this formula is integral formula, right? So integral of n times x to the n minus 1 dx, that should be x to the nth powers plus c. If you plug in n plus 1 instead of n, that can be changed n plus 1 times x to the n plus 1 minus, that is just n dx is equal to x to the n plus 1. I just replace n with n plus 1. N plus 1 is just a number. So can go to front by the first rule and then divide by n plus 1. So n plus 1 gonna be here. So integral x to the nth powers dx is equal to 1 over n plus 1 times x to the n plus 1 power plus c. This book used u instead of x because of u substitution. I'll explain u substitution later. Okay, you memorize with u, variable u or variable x, that doesn't matter. Anyway, you can memorize all these formulas to use it. Okay, and the next formula, what is integral 1 over u du over u, this part. I'm going to change it to x, right? I change like that, 1 over x dx. Okay, do you remember that? ln x prime, that was 1 over x, right? So the backward of the derivative is integral. That's why integral of 1 over x equals ln x plus c. But in ln, these numbers should be always positive, right? Cannot be negative number. So put the absolute value on that x. So integral 1 over x dx is equal to ln absolute value x plus c. That's the final formula. The sine's derivative of the cosine. That's why integral cosine is what? Sine x plus c. What was cosine's derivative? Negative sine, right? Cosine x prime was negative sine x. So integral of negative sine x dx should be cosine x plus c. So multiply negative 1 and negative on both sides. So integral sine x is negative cosine x plus c. What about tangent x? We have no any formula, any function's derivative is equal to tangent. We don't have it. So it's kind of new formula, you have to memorize it. So tangent u is equal to ln absolute value of secant u, or I just use the second one more than first one, negative ln absolute value cosine u plus c. I'll prove this formula later to use u substitution. Okay. All right, next formula, cotangent, integral cotangent. It is ln sine absolute value sine u plus c. It is a brand new formula as well. Next formula, you know tangent x, right? Tangent x, derivative was secant square x. So backward is integral secant square x dx equals tangent x plus c. You can use u, any variable, that doesn't matter. Okay, I'm using x now. What about cosecant square? Cotangent x derivative was negative cosecant square x. That's why integral cosecant is equal to negative cotangent u plus c. And then secant u's derivative was secant u tangent u. Secant x derivative was tangent x secant x. So integral secant x tangent x dx equals secant x plus u. Same thing. Cosecant was what? Derivative of cosecant x equals negative cosecant x times cotangent x. That's why backward of that formula, integral cosecant to u cotangent to u du is equal to negative cosecant to u plus c. Okay, there's another couple of more new formula. Secant in x and then cosecant x. Integral secant u du is ln absolute value secant u plus cotangent u plus c. Cosecant u's integral is ln absolute value cosecant u minus cotangent u. It is plus, it is minus. What was derivative of e to the x powers? E to the x derivative was e to the x. So integral e to the x dx equals to e to the x plus c. What about a to the x powers? What was derivative of that? That is a to the x powers times ln a. That was the formula, right? So backwards is integral. So integral a to the x times ln a dx is equal to a to the x plus c. So integral a to the x dx I'll divide by ln a. So a to the x over ln a plus c. This is the formula. Integral a to the u du equals a to the u over ln a plus c. Sine inverse arc sine x derivative was 1 over square root 1 minus x squared, right? That's why integral 1 over square root 1 minus u squared du is equal to sine inverse u plus c. Or arc sine u plus c. Same thing. What about tangent inverse functions derivative? There was 1 over 1 plus x squared. So integral 1 over 1 plus x squared dx equals tangent inverse x plus c. Or arctangent x plus c. And then you memorize one more, arcsecant. Secant inverse, absolute value of u. That derivative was 1 over u times square root u squared minus 1 du. So integral of 1 over u square root u squared minus 1 du is equal to secant inverse absolute value of u plus c. It's 19 formulas. This book introduces you 19 integral basic formulas. Today, I'm not going to solve all example problem, but I'll solve some example problems. And then in the next video, I solve the other example problems with u substitution together. Okay, let's start some example problem. Example 1 is a very easy problem. Integral 5x dx. So 5 is a coefficient, can go to front. 5 times integral x dx. So x means x to the fourth power, right? So integral x to the fourth power dx, it is 1 over n plus 1, n is 1, 1 plus 1 times x to the n plus 1 plus c, so 1 over 2 x squared plus c. So this part is 1/2 x squared. So 5 times 1/2 times x squared plus c. So this is the answer. Example 2. Just you can find each function's integral. Each function's integral using usually power. So integral of x to the fourth. So what is the formula? X to the nth powers dx is equal to, what was the formula? 1 over n plus 1 times x to the n plus 1 plus c was the formula, right? So first part, n is 4. That's why 1 over 5 x to the fifth powers from the first function. And then what about this? Use the same formula, n is 2/3. So integral of the second part is what? 1 over n is 2/3, 2/3 plus 1 times x to the 2/3 plus 1 powers plus c. So it is 1 over 5 over 3, 3 over 5, 3 over 5 times x to the 5 over 3 powers. So the second part is here. And then third part, negative 2 over x squared. So negative 2 over x squared, we can change that negative 2 times x to the negative second power. So integral of this part, negative 2 is still negative 2. And then this part n is negative 2. So 1 over negative 2 plus 1 times x to the negative 2 plus 1 plus c. So this part is going to be positive 2. And then this part is x to the 1 negative first power, 2 over x. So second part is 2 over x. And the last part is this, right? It is 1/3 of the coefficients, right? So 1/3, negative 1/3 times integral 1 over cube root x. Cube root is 1/3 power, so x to the negative 1/3 power. N is 1/3 power. So integral of this part, negative 1/3 times 1 over negative 1/3 plus 1 times x to the negative 1/3 plus 1. This part can be just 1/2, negative 1/2, and then this part is x to the 2/3 powers. So there is negative 1 over 2, x to the 2/3 power. So last part is going to be here. And then add integral coefficients c. So this is the final answer. Just find that each part's integral using same formula. Next problem, example 3. Example 3 is easier. So just each part integral as well. So any numbers, integral of any number dx, actually the kx plus c. You know, what function's derivative is 3? 3x derivative is 3, right? Look at that. 3x prime is 3. That's why integral of 3 is 3x. The first part is what? 3x. Second part, negative 4x. So negative 4 times integral x dx. Integral x dx is 1 over n is 1 in this case. N plus 1, 1 plus 1 times x to the 1 plus 1. So 1/2 x squared times negative 4. So negative 2x squared. That's the second part. The last part, 2 is coefficient came out. And then this part is 1 over 3 plus 1 times x to the 3 plus 1. So 1 over 4 times x to the 4th times 2. So 1/2 x to the 4th. So third part is x to the 4th over 2 and plus c. So example 1 to 3, I just use only one formula, right? Yeah, power integral over time. X to the nth power dx is equal to what? 1 over n plus 1 times x to the n plus 1 plus c. I kept using this formula. Okay, I'm not going to solve example 4. I'll explain U substitution in the next video, and then I'll solve some U substitution problem from example 4. So next video, I'll start from example 4. Thank you so much for watching my video. Please click subscribe and like and turn on the notification. Thank you so much again.